Welcome to Daily AI Brief, your go-to podcast for all the latest in artificial intelligence, technology, innovation, and challenges. Today, we're diving into 10 diverse segments that reveal the fascinating intersection of AI advancements and the complexities they bring to various fields. From enhancing cybersecurity to transforming neuroscience research, we've got a packed episode full of insights and knowledge. With AI-driven threats on the rise, traditional cybersecurity measures are struggling to keep up. Recent insights from IBM's 2026 X-Force Threat Intelligence Index have shown a worrying trend, with a 44% increase in attacks on public-facing applications identified through AI-enabled vulnerability discovery. This development poses significant risks as businesses experience a spike in attack vectors, notably from ransomware groups, which surged nearly 50% in the same period. IBM and other organizations are integrating AI into cybersecurity for enhanced threat detection and response. Existing technologies like the Autonomous Threat Operations Machine (ATOM) and new AI-powered threat detection services help automate and streamline defenses. However, many IT leaders feel their security measures are outdated, emphasizing a push towards proactive security measures. Integration and enhancement. The integration of AI into security operations enhances both the detection and remediation of threats. IBM's ATOM is pivotal as it automates threat triage, allowing for rapid intelligence gathering and prioritizing critical incidents. This system effectively reduces the burden on human analysts and aids in focusing on complex tasks that require human intuition. Moreover, IBM's AI-powered threat detection services are designed to reduce the incident response time significantly by automating up to 85% of alerts. This capability ensures that routine threats are managed efficiently, while human experts can address novel or sophisticated attacks. Real-time escalation and closure of alerts improve organizational efficiency, maintaining a proactive stance against potential threats. Challenges and trade-offs. While these AI solutions offer powerful defenses, there are inherent challenges. High reliance on automated systems could potentially introduce blind spots in threat detection. The complexity of integrating these new solutions with existing cybersecurity architectures further complicates deployment processes. According to surveys, 65% of IT leaders express concern over the adequacy of their current defenses, with worries that the rapid evolution of AI threats may outpace current countermeasures. Practical steps forward. For organizations looking to strengthen their cybersecurity posture, exploring IBM's autonomous security platform is a crucial step. This platform integrates AI to handle complex threat environments more efficiently. Implementing AI-powered threat detection services can streamline alert management and provide a more strategic allocation of resources. Regularly reviewing reports such as the 2026 X-Force Threat Intelligence Index can offer valuable insights into evolving threat landscapes. Conclusion. The battlefield of cybersecurity is rapidly changing, and to stay ahead, proactive measures coupled with AI integration are not just beneficial, but essential. As the landscape evolves, organizations must adapt and embrace advanced technologies to safeguard their networks against increasingly sophisticated AI-driven cyber threats. The context gap in AI systems presents significant challenges in real-world applications, as recent research points out. AI models that perform well in controlled environments often falter when scaled to enterprise levels due to fragmented data management and governance complexities. This disparity points to the need for a cohesive framework integrating data governance and system design to successfully implement AI technologies across sectors. IBM's introduction of the Watson-X.Data platform aims to tackle these issues. This solution targets data management problems by integrating data, governance, and workflows to create scalable AI solutions. Key processes include 1. Addressing fragmented data and governance. The platform unites disparate data sets and centralizes governance policies to alleviate issues caused by inconsistent definitions and siloed data streams. 2. Building scalable frameworks. IBM's Watson-X.Data focuses on crafting comprehensive frameworks that support AI scalability, utilizing APIs for seamless data integration, which ensures systems remain responsive and adaptive to real-time changes. Encouraging cross-departmental collaboration. A successful AI implementation requires strategic involvement from various departments. IBM underscores the need for aligning AI strategies with business objectives through interdepartmental synergy. 4. Utilizing advanced tools. Tools for real-time data integration are pivotal. By leveraging such technologies, AI systems can maintain operational efficiency and accuracy in dynamic settings. Though the WatsonX.data platform offers solutions, operational complexities remain a significant hurdle, as highlighted by IBM's research, which indicates that many AI projects fail due to these rather than model performance issues. Hence, engaging strategic stakeholders in AI project planning becomes essential. This involvement can mitigate risks and align AI deployment with overarching enterprise goals effectively. Practical steps to bridge this gap include exploring IBM's WatsonX.data for insights on effective data integration, utilizing IBM's governance strategies for agentic AI, and actively involving stakeholders in every phase of AI planning. The pressing takeaway from these initiatives is clear. Adopting a unified approach that marries data integration, governance, and organizational workflows is crucial to successfully scale AI solutions in enterprise environments, thereby unlocking potential competitive advantages through intelligent AI deployment across various industries. WaveMaker's introduction of a two-pass compiler model marks a significant leap in AI code generation reliability. This approach strategically separates the compilation process into two distinct stages. The initial stage generates a meta-model using WaveMaker markup language, WML, while the subsequent stage transforms this model into clean, framework-ready code without AI intervention. By restoring deterministic characteristics to code generation, this model addresses challenges typically associated with AI-driven generation. Diving into the technical specifics, the two-pass compiler consists of a meticulous architecture. First pass, meta-model generation. This phase involves converting design inputs or prompts into a meta-model using WML. This language acts as a specification guide, offering a comprehensive description of the user interface, thus enabling a structured and predictable layout reminiscent of traditional code design. Second pass, code transformation. Here, the functional code is generated from the WML metamodel without AI involvement. This ensures that the resulting code is clean, framework-ready, and adheres to standard patterns, minimizing the model drift typical in AI-driven systems. This dual approach enhances error detection capabilities and allows for better optimization techniques, significantly more effective than single-pass compiler systems. On the competitive front, Anthropic's advancements with 16 parallel instances of its Claude Opus 4 AI further highlight the dynamic field of AI-driven software development. Their successful autonomous construction of a fully functional C compiler in just 2 weeks clearly demonstrates AI agents' potential to streamline development efforts immensely. Despite the successes, this intensive project required substantial resources, incurring approximately $20,000 in API fees and producing 100,000 lines of Rust code. This massive codebase successfully compiled software for Linux version 6.9, emphasizing the efficiency and power such AI-driven initiatives can achieve. However, adopting a two-pass approach isn't without its trade-offs. The initial overhead is notably higher compared to single-pass models due to the additional processing stage, which may not only prolong initial setup times, but also involve greater computational resources. Potential unpredictabilities persist, especially concerning varied user inputs, and further research may be necessary to gauge the system's adaptability to more elaborate software projects. For those interested in exploring this groundbreaking technology, you can try WaveMaker's two-pass compiler by visiting this link, it's wavemaker.ai/2pass/UTM source OpenAI. To further understand how it stands against traditional models, check out the differences between single-pass and two-pass compiler architectures by clicking here, geeksforgeeks.org, compiler design/single-pass, two-pass, and multi-pass compilers/UTM source OpenAI. The strategic adoption of two-pass compilation models could redefine AI code generation standards, particularly in the realm of enterprise applications. By addressing typical pitfalls of AI-driven methods and enhancing the reliability of generated code, it paves the way for broader integration of AI into critical software development tasks, promising a future where efficiency and determinism can go hand in hand. UC San Diego and Together AI have introduced Parcae, an innovative architecture that enhances looped language models' efficiency and stability without extra memory. This breakthrough claims to match the performance of a 1.3 billion parameter transformer using just 770 million parameters, demonstrating Parcae's potential in resource-constrained environments like edge devices. Technical breakdown. The brilliance of Parcae lies in its looped architecture grounded in dynamical systems theory, which offers several advances over traditional models. The principle revolves around enhancing stability through a recurring mechanism that scales quality rather than merely increasing data size. This approach ensures that the model's parameters are utilized more intelligently, thereby needing less memory. Parcae effectively addresses common issues like loss spikes and residual explosions, challenges often faced by existing looped models. By mitigating these spikes by up to 6.3% in validation perplexity compared to prior models, Parcae achieves a remarkable improvement in stability and training efficiency. Numbers and benchmarks. Numerically, Parcae's design showcases a significant leap. The adoption of a 770 million parameter configuration not only rivals models with 1.3 billion parameters, but also underscores efficiency without compromising performance. This reduction in parameters translates into less computational demand, which is crucial for applications in low-power environments such as mobile devices. Real-world applications and limits. While these benchmarks are promising, real-world deployment testing is essential to validate Parcae's effectiveness comprehensively. Potential risks include performance variability in non-ideal conditions, scenarios often encountered outside controlled experimental setups. Long-term stability and efficiency across diverse datasets and tasks also need rigorous examination. #Future Exploration. Interested in more detailed insights? Access the Parcae model paper on Arxiv here. arxiv.org/abs2604.12946 for an in-depth overview. Explore the Together AI blog Together OpenAI. Implications. The implications of Parcae's architecture extend far beyond its immediate performance gains. It heralds a shift in language model research, emphasizing stability and architectural innovation over sheer scale. This could inspire new developments in AI applications, especially in sectors demanding efficient computation, such as edge computing. Moreover, Parcae challenges the prevailing notion that larger parameters are necessary for better accuracy, pointing instead to smarter model design as the key to future advancements. As the field moves towards maximizing computational efficiency, models like Parcae provide a compelling roadmap for future innovation in AI design strategies. InsightFinder, focusing on AI reliability in production, may have raised $15 million in Series B funding led by UGalaxy. Despite no verifiable confirmation of this funding, InsightFinder remains steadfast in its mission to enhance AI reliability in enterprise environments by leveraging predictive solutions to anticipate and avert IT incidents. Founded in 2016 by Dr. Helen Gu, InsightFinder employs advanced machine learning algorithms to analyze IT data efficiently. The focus is on minimizing disruptions by integrating with existing IT management systems and providing predictive insights, enabling enterprises to take preemptive actions against potential system failures. This approach not only conserves valuable resources, but also optimizes the performance of critical systems. The platform offers several key features. Predictive analytics. InsightFinder analyzes historical IT data to forecast potential issues before they escalate. This capability is crucial as it helps to mitigate risks proactively, ensuring smoother operations. Real-time data analysis. By integrating with monitoring tools, enterprises can achieve real-time insight into their IT environments, allowing for timely interventions. Scalability and accessibility. Through a cloud-based architecture, InsightFinder ensures scalable solutions that support extensive data processing needs and facilitate accessibility across various enterprise locations. InsightFinder previously secured $10 million in Series A funding with contributions from notable entities such as UGalaxy. While the potential Series B remains unverified, The company aspires to reduce enterprise downtime by 30 to 50% and improve operational efficiency by at least 20%. These ambitious targets highlight the platform's potential impact on enterprise productivity and reliability. However, challenges persist. The platform's predictions rely heavily on the quality of historical data, which introduces a degree of uncertainty. The possibility of biases in machine learning predictions cannot be overlooked, and enterprises need significant time and resources for initial integration. For those interested in exploring InsightFinder's capabilities, practical steps include visiting their website for demo requests and platform trials. Additionally, comprehensive documentation is available to assist with API integrations, enabling seamless integration with existing IT service management solutions. InsightFinder's endeavors emphasize the transformative potential of AI in enhancing operational resilience. Although the confirmation of new funding is still awaited, its commitment to AI reliability could substantially alter enterprise IT operations, setting new benchmarks for downtime reduction and efficiency gains. The broader implication suggests that as AI solutions become more integrated into business functionalities, the demand for robust and reliable AI-driven methods will escalate, inevitably reshaping industry standards and practices. Amazon Web Services has introduced automated reasoning checks within Amazon Bedrock guardrails to fortify AI-generated output compliance. By integrating formal verification techniques, AWS seeks to ensure that AI applications meet regulatory standards, especially in tightly regulated sectors like finance and healthcare. This innovation claims up to 99% accuracy in validating AI model responses, setting AWS as a pioneer among cloud service providers by embedding formal verification into their generative AI suite. The technical backbone involves utilizing formal verification methods. These methods translate input documents into formal logic structures, providing a robust framework to validate AI outputs against predefined rules and domain knowledge. The system supports integration into existing AI workflows, allowing developers to receive actionable compliance feedback seamlessly. This integration helps maintain adherence to complex regulatory landscapes, reducing the risk of non-compliance and regulatory infractions. However, the tool has certain constraints. One major limit is the input document size, capped at 5 megabytes or 50,000 characters, restricting the amount of data processed at once. This could potentially introduce latency, especially in environments requiring real-time AI decisions. It's crucial for businesses to ensure their input data is structured clearly, as any ambiguity could compromise the tool's effectiveness and lead to issues, such as validation errors in complex policy frameworks. AWS guides developers and enterprises through comprehensive documentation, offering step-by-step instructions to integrate automated reasoning checks efficiently. It also highlights best practices for crafting automated reasoning policies, ensuring that users leverage the technology's full potential. Testing within the framework's limits helps achieve optimal outcomes, making it essential for developers to familiarize themselves thoroughly with these guidelines. This initiative enhances the compliance landscape for AI implementations, reducing risks associated with misleading AI outputs and boosting trust in AI tools. As AWS sets a precedent, other cloud service providers might feel an impetus to adopt similar measures, driving innovation in AI compliance solutions industry-wide. While challenges such as processing latency and size restrictions persist, the potential for automated reasoning to transform how enterprises manage compliance in AI-driven applications is significant. This could also minimize legal liabilities for businesses deploying generative AI, signaling a shift towards more reliable and mature AI compliance practices. Amazon has launched a cost-efficient solution for custom text-to-SQL generation by integrating the Nova Micro model with Amazon Bedrock. This initiative acknowledges the pressing need for accessible data exploration by converting natural language questions into SQL queries, easing the path for non-technical users to engage with complex datasets without requiring deep expertise in SQL. The technical capabilities of the Nova Micro model are designed to capitalize on Amazon Bedrock's robust foundation models, excelling at natural language processing tasks. This advancement is a strategic component of AWS's broader AI deployment framework, offering a seamless API integration that allows developers to embed these capabilities directly into existing business applications. The power of this solution lies in its ability to deliver performance and cost-effectiveness tailored to enterprise-level needs. In terms of performance, while specific latency benchmarks are not disclosed, Amazon emphasizes the model's optimization for low latency and cost efficiency. The Nova Micro model, part of the larger Nova family, is expected to handle enterprise workloads dynamically, addressing complex queries with agility. The introduction of such a model strengthens AWS's position against established competitors like Google Cloud, known for its AI-driven database solutions, and Microsoft Azure, with its robust database management tools. For those interested in exploring how Nova Micro can be utilized, the Amazon Nova Model's user guide serves as an invaluable resource. It provides a detailed walkthrough of integrating these services into applications. Meanwhile, AWS's blog posts regularly feature implementation examples and discussions on practical applications of text-to-SQL solutions. Adopting Nova Micro can significantly streamline the querying process for organizations, reducing reliance on traditional SQL experts. This represents a substantial shift in how businesses approach data analytics, enabling broader access to business intelligence tools. However, it is essential to note that, while the performance claims are promising, the absence of concrete benchmarks and detailed pricing poses challenges for potential adopters regarding transparency and planning. These offerings also open up potential for small and medium enterprises to innovate, leveraging AI tools without burdensome infrastructure investments. While the framework could inspire similar competitive offerings, particularly as the market reacts to AWS's moves, Amazon's focus on enhancing user experience denotes a strategic alignment with customer-centric innovation. As AWS continues to refine this solution, its implications could be far-reaching, potentially reshaping how data-driven insights are accessed and utilized across various sectors. The convergence of cost-effective AI frameworks and streamlined data query processes may well drive a new wave of innovation in cloud computing, enhancing accessibility to crucial data insights beyond traditional boundaries. Google Research's Mojin model is set to transform brain mapping with its innovative flow matching approach that generates synthetic neurons. This breakthrough promises significant advancements in neuroscience by providing high-resolution 3D point clouds of neuronal structures. Such precision facilitates a deeper understanding of neural connectivity, a critical area in neuroscience research for unraveling how brain functions manifest from microscopic neuron interactions. Technical drill down. 1. Flow matching techniques. Mojin utilizes flow matching techniques to produce detailed 3D point clouds that represent various components of neuronal structures, such as axons and dendrites. This method leverages sophisticated algorithms to ensure that each synthetic neuron accurately reflects its real counterpart. The use of high-resolution detail enables a level of accuracy and fidelity in synthetic neuron generation that was previously difficult to achieve. 2. Scalable latent transformers. The model employs a scalable latent transformer architecture, which incorporates local geometric context to enhance the realism of neuronal morphologies. By adapting to intricate local geometries, Mojin can create diverse shapes and sizes of neurons, an essential factor given the complexity and variability present within biological neural networks. 3. Evaluation suite. Mojin introduces a dedicated evaluation suite designed to assess both geometric and topological features of the neurons it generates. This suite ensures that the synthetic neurons are not only visually accurate, but also functionally representative of real neuron behavior. Metrics are used to evaluate aspects like fidelity, scalability, and efficient reproduction of neuron structures. Numbers and benchmarks. The Mojin model aims to deliver up to a 10-fold increase in efficiency compared to traditional neuron generation methods. This dramatic enhancement in efficiency is crucial for projects requiring the analysis of vast neural data sets, where speed and accuracy are paramount. What to try? For researchers and practitioners in the field, accessing the Mojin paper from ICLR 2026 offers foundational insights into the model's architecture and functionality. Utilizing the provided datasets can open up practical applications in connectomics, allowing researchers to apply these synthetic neurons to real-world problems in neuroscience. Trade-offs and limits. Though promising, Mogen's synthetic neuron model faces challenges, such as the need for validation in real-world scenarios. Biological variability is a significant factor, and while synthetic neurons offer substantial detail, they may not capture all the nuances of actual neurons. The generalizability across species, from animals like zebrafish to mammals, also remains an open question. Implications. The successful implementation of AI-generated synthetic neurons could streamline brain mapping processes, reduce research costs, and improve the quality and accessibility of high-resolution neural data. By enhancing collaboration opportunities and speeding up discoveries in neural connectivity and brain disorders, models like Mogen may significantly influence AI's role in advancing neuroscience. Controversies and uncertainties. There are ongoing debates regarding the reliability of AI-generated models in biological contexts. Questions surround the accuracy of synthetic neurons compared to manual mapping methods, the potential for oversight, and the nuances in handling complex neural data. In conclusion, while the Mogen model represents a step forward in AI applications for neuroscience, the path to broad adoption involves addressing these validation challenges and ensuring its applications are both scientifically sound and practically deployable. On March 24, 2026, OpenAI announced the deprecation of its AI video generation tool, Sora, a service that had launched in late 2024 with the vision of democratizing video content creation. This unexpected closure, announced in a brief post on X, has left many users scrambling for alternatives and evaluating the stability of AI platforms. In response to Sora's end, OpenAI has recommended tools like Google's Veo 3.1 and ByteDance's Seedance 2.0, both of which cater to current production needs and promise enhanced capabilities. Sora, during its run, utilized AI-based algorithms tailored for text-to-video generation. However, stiff competition and an evolving tech landscape seemingly challenged its viability. As a result, Veo 3.1 emerges as a strong alternative, particularly because of its integration with Google's Gemini platform. This integration supports robust multi-scene storytelling with 4K resolution, offering a versatile foundation for content creators. Priced at $7.99 a month for the AI Plus tier, Veo 3.1 also provides a cost-effective option for both small startups and large enterprises. Conversely, Seedance 2.0, launched in February 2026, has carved a niche by focusing on music-synchronized videos and dance choreography. Its unique features allow content creators to align video elements with musical rhythms seamlessly, enhancing the artistry and precision of video projects oriented towards entertainment and social media. Complementary to these choices, Runway Gen 4.5 and Kling AI 3.0 present other formidable options. Runway Gen 4.5 boasts an extensive editing suite, allied with AI video capabilities, appealing to users needing intricate customization. Meanwhile, Kling AI 3.0 is celebrated for strong motion realism and an intuitive user interface, easing user adoption and shortening the learning curve. The unexpected discontinuation of Sora raises important questions about the sustainability of AI-driven video generation tools. As organizations and independent creators shift from Sora to platforms like Veo 3.1 or Seedance 2.0, they face the challenge of retraining efforts and integration hurdles, a common trade-off during technology migrations. There is also speculation about industry trends and future viability, with concerns regarding whether rapid shifts might enhance or impede long-term growth for AI creative tools. This event underscores the importance of evaluating not just current capabilities, but also the stability and future trajectory of AI platforms. For those making the transition, practical steps include testing potential solutions, understanding monthly costs versus features, and considering project-specific demands, such as whether storytelling depth or synchronized video output is more crucial. Staying informed and adaptable will be key for creators navigating this vibrant yet unpredictable landscape. The Stanford AI Index 2026 provides an essential overview of the current state of artificial intelligence, illustrating both the breathtaking pace of technological innovation and the challenging lag in governance frameworks. The report reveals that over 90% of the leading frontier models developed in 2025 emerged from the industry, highlighting a significant shift towards private sector leadership in AI growth. This rapid progression underscores a pressing need for alignment between technological advancements and ethical oversight, especially as the number of AI-related incidents has surged by nearly 55% from 233 in 2024 to 362 in 2025. In particular, the United States dominates AI infrastructure, boasting 5,427 data centers, a staggering figure that outpaces other nations by more than tenfold. This infrastructure has supported the extraordinary adoption of generative AI, now at 53% within a mere 3-year span, outstripping the adoption rates of previous technological milestones such as personal computers and the internet. Yet this explosive growth is not without significant challenges. The emission profile from AI model training is alarming. The environmental impact is substantial, with recent models contributing over 72,000 tons of carbon equivalent emissions, a testament to the need for sustainable AI practices. The inconsistency in AI performance across various domains remains a technical hurdle, showing proficiency in areas like competitive exams, yet still struggling with seemingly basic tasks such as reading analog clocks. To better understand AI's trajectory, the full 2026 AI Index report is an invaluable resource, providing detailed insights into ongoing advancements and necessitated governance strategies. One crucial recommendation is the integration of AI policies into educational curriculums, specifically targeting the 50% of middle and high schools currently lacking such initiatives, even though over 80% of students reportedly use AI for academic purposes. The key takeaway from the Stanford AI Index 2026 is clear. AI's relentless pace of development requires governance to keep stride to mitigate potential adverse societal impacts. This dual emphasis on technological innovation and proactive policy development is critical to fostering public trust and ensuring AI's benefits are maximized responsibly across all sectors. That's all for today's episode of Daily AI Brief. We've explored a spectrum of topics from cybersecurity and compiler innovations to AI's impact on neuroscience and video content creation. As AI continues to transform our world, both challenges and opportunities will emerge. Stay curious, stay informed, and join us next time for more insights into the ever-evolving world of artificial intelligence.